Namaste and welcome to Apna Gurukul Maths. One little step towards success. We are discussing the chapter 2 of NCERT Maths, and that is polynomials. We have already discussed till remainder theorem. That was a very important theorem. Now we have an extension of remainder theorem, which is called as factor theorem. That is our objective and the focus of this particular video. It will be a little longer video because there are few things which are easy but a little longer. Let's get going into this chapter. First thing, are we clear with the remainder theorem and how to use remainder theorem? Quickly revise what is remainder theorem. Let's p of x be a polynomial, okay, and polynomial of degree greater than or equal to 1. That explanation I've already done. Why is it so? If you are not clear, go to the playlist and you will be able to find the remainder theorem video. So, and let a be the real number. If p of x is divided by the linear polynomial x minus a, then the remainder is p of a. Now, as I already told, what is factor theorem? It's an extension of remainder theorem. How? Let's try to understand. Again, we will try to understand with the basics, that is division algorithm. We'll take help of division algorithm. Now, division algorithm I have been discussing a lot of times, so I hope you will never forget what is the division algorithm is. Let's quickly understand. So suppose I have 6 divided by 2, obviously it is 3. So if I have to write it in division algorithm form, dividend is equals to divisor multiplied by quotient plus remainder is 0. So what do we do? Say according to this, that 2 and 3 are factors of 6 and 6 is a multiple of 2 and 3. I hope that makes a lot of sense. Yep. So similarly, for polynomials, what do we have? Similarly, for polynomials, suppose we have a polynomial p of x which is 4x cubed plus 4x square minus x minus 1, and we have a g of x which is 2x plus 1, and we are dividing p of x by g of x. So in this situation, let's find out the remainder. So obviously what will be the 0 of 2x plus 1? 2x plus 1 equals 0. So if you calculate that, you will get x equals minus 1 by 2. So if you do p of minus 1 by 2, we are finding it to be 0. Let's quickly verify that so that there is no confusion left for us. So p of minus 1 by 2, p of minus 1 by 2, when we start calculating, that is equals to, instead of x, we are substituting minus 1 by, so 4 by 1, minus 1 by 2 to the power 3 will be minus 1 by 8 plus 4 times minus 1 by 2 whole square is 1 by 4 minus x is obviously minus 1 by 2. So I'll keep the bracket intact so that there is no confusion left. Now, as you can see, 4 ones are and 4 twos are, we can cancel out because there is a multiplication. So I'm left with minus 1 by 2 plus 4. It is in multiplication, so 4 times 4 gets cancelled. So I'm left with 1. Minus of minus 1 by 2 is plus 1 by 2 minus 1. So minus 1 by 2 and plus 1 by 2 gives 0, plus 1 and minus 1 gives 0. So that is equals to 0. So p of minus 1 by 2 is 0. Yes. So then, can we write according to division algorithm that p of x, the complete polynomial, this is equals to 2x plus 1 multiplied by q of t, where q of t is the quotient. It is also a quotient polynomial, right? It is also a polynomial, and obviously when you divide, you obviously get a polynomial. So this polynomial do exist and the remainder is 0. So therefore we can say that 2x plus 1 is a factor of p of x. So what do you understand? We took help of the remainder theorem and then we showed that what is the possibility of the divisor being a factor. This is what is the factor theorem. Let's understand the statement of factor theorem. It says if p of x be any polynomial, okay, of degree n is greater than 1, and let a be any real number, the obviously first statement of remainder theorem, then x minus a is a factor of p of x if p of a equals 0. That means if the remainder, P of A is nothing but remainder, right? So if the remainder is 0, then x minus A will be a factor. Now, in mathematics, whenever we have a theorem, we also try to look forward its converse. What is the meaning of converse of the statement is, suppose you have a theorem which says, if statement A is true, then B is also true. B is also true. Yes. Now the converse of this will be, if B is true, then A will also be true. I hope you have understood the meaning of converse. Now in factor theorem, the first statement says x minus A is a factor of P of x if P of A is 0. That means if P of A is 0, that is the remainder 0, then x minus A will be factor. Now the other way around. Now P of A equals 0 if x minus A is a factor of P of x. Now here it is given that x minus A is factor of P of x. That is when we conclude P of A equal to 0. The first statement is P of A is given as 0 and we conclude x minus A is a factor. So both are opposite statements, and that is what we will try to prove as well, because proving is always important and proving gets you the clarity. Now we will try to prove it with the help of remainder theorem and the division algorithm. Don't scold me that I'm again remainder theorem and division algorithm. Don't scold me that I'm using division algorithm so again and again. It is important. Let's try to understand proof of factor theorem. So again, by the remainder theorem, we know that P of x equals x minus A. Now we have written in form of division algorithm, and that is why it is very, very much important. When I was explaining, I told you, right? So P of x equals x minus A. Obviously, it's the divisor times quotient Q of x. Remainder is P of A. So we have directly written over here P of A. Now let's try to prove the first statement. First statement, what does it say? That if P of A is 0. So if P of A is 0, then obviously this will be 0. So that means we are left with P of x equals x minus A times Q of x. So similarly, means by this itself, we are able to see that x minus A is a factor of P of x, because this is in the form of, suppose I'm writing 2 equals 2 times 6 in case of numbers. So we clearly say that, right? 2 and 6 are the factors of 12. Similarly, x minus A and Q of x both are factors of P of x over here. I hope that makes sense. Now, the other statement, since now what is given over here, x minus A is a factor of P of x. Yes. Now, when this is given, P of x, now we can also write that implies P of x equals x minus A multiplied by G of x. Since it's a factor, obviously it will be written in this form. Why? Because suppose 12 is equals 3 times 4, right? So 3 and 4 are the factors. We write it like this. We do not add any remainder, right? That is the way we write according to division algorithm, where G of x is some quotient, and we have written just for some polynomial G of x. Yes. So now in this case, suppose I take P of A. I'm trying P of x, right? So instead of x, I substitute the value of A, because we want the value of P of A. That is what is the remainder, right? So P of A I have substituted. So instead of x, I substituted A. G of x became G of A. So since A minus A is 0, 0 multiplied by G of A, we are not worried what is the value of G of A, because it will give us the value as 0. So what do we get? P of A equals to 0. That means we have proved both the statements very, very clearly. Right? Now, what is the meaning of proof in a proof of any theorem is, whatever we know already, we take help of whatever theorems, whatever statement we know already, we take help of all those statements and modify this, try to mold it and produce a new theorem. That is what we do in a proof, right? Whatever we have already known, we just try to implement that. Yes, so that is what is done in proof. Let's do go for a few questions. Generally, you are asked two type of questions. Number one is, we have to check whether x plus 2 is a factor of this particular polynomial or not. How do we check? We find the remainder using remainder theorem. If it is the remainder is 0, then by using factor theorem, we say that this polynomial is a factor of sorry, x plus 2 is a factor of p of x. I will name this polynomial as p of x. Why to say every time this polynomial? So x plus 2 is a factor of p of x. So we will do that particular question very quickly. Now I hope you all know how to present the answer when it is asked in examination. Now from examination point of view only, the presentation of the answers is also very much important. I'll make a separate video itself to show you how to present answers in your examination, because examination, as I told, presentation is a little bit important thing. Although I've already told, we are not focused on examination, we are focused on learning. But let's begin. So over here, x plus 2 is a factor of, we have to check it. So first of all, find the 0 of x plus 2, that means x equals minus 2. So that means we have to find the value of p of minus 2. Yes, very quickly we can do it. So x cube we have, so we will find minus 2 cubed plus 3 times we have to find minus 2 whole square plus 5 times minus 2 plus 6. Yes. So when we try to solve this, we get minus 2 cubed is minus 8 plus 3 times minus 2 square is plus 4, right? Minus 2 square is plus 4. Minus 2 times minus 2, minus minus becomes a positive. 2 times 2 becomes 4. So 4 times 3 is 12. And then 5 times minus 2 gets us minus 10 plus 6, obviously. So let's try to solve it further. Minus 8 plus 12 is 4, minus 10 plus 6 is minus 4. 4 minus 4 is 0. That means p of minus 2 is coming out to be 0. That means the remainder is 0. If the remainder is 0, what does the factor theorem says? That x plus 2 is a factor of p of x. I hope that makes a lot of sense for you. Now, here we have the other question. Find the value of k if x minus 1 is a factor of 4x cubed plus 2x square minus 4x plus k. What is the meaning of that? That if you, since it's a factor, the remainder will be 0. What is the way to find the remainder? Let's suppose I name this polynomial as q of x. So q of the root of divisor. So root divisor is x minus 1. Let's find it 0, or root x minus 1 equals 0. So that means x equals 1. So if you find the value of q of 1, it should be equal to 0 because it's a factor. Yes. So 4 times 1 cube is 1 plus 2 times 1 square is also 1 minus 4 times 1 is 4 plus k equal to 0. So we get 4 plus 2 minus 4 plus k equals to 0. 4 plus 2 is 6 minus 4 is 2 plus k equals 0. Now k will be 2, goes to the other side, it gets you to minus 2. So the value of k over here is minus 2. I hope this makes a lot of sense to all of you. Now, generally, whenever we have such theorems, we have similar problems where we apply these theorems. Now, these are very mathematical applications. Now, I will be making one video where I'll show you lots and lots of real life application. That will be a very fun video. I would love for you to watch that video. It will be coming very soon. I'm working on a lot of problems, and as well as I've told you, on every chapter we'll try to do around 150 questions. So that particular video will also be coming very soon. So let's use factor theorem for factorization. So factorization, what is the meaning of factorization? We have a term given, or over here we have a polynomial given. We have to find its linear factors. What do we mean by linear factors? Linear factors are nothing but if you find the zeros of that factor, it will give you the remainder 0. Yes or no? That is why we need to understand these questions. So let's get going. So factorize p of x equals x square minus 5x plus 6. Now this is a quadratic equation. Yes, why quadratic equation? Because it has degree 2. Now there are two ways to do it. One way is very easy, means splitting the middle term. So that is x square minus 5x plus 6. You will split the middle term, that is minus 5x. So that method we all are very comfortable with. We'll quickly revise that method. So over here, the coefficient is 1. So 1 times 6 is 6. So that means we have to split minus 5 in such a manner that its multiplication is plus 6. I'm sorry, plus 6, and its addition is minus 5x. So obviously x square minus 3x minus 2x plus 6. So minus 3 times minus 2, if you do, you'll get a plus 6. That means our splitting is correct. So we'll take common factor. So if I take x as common from here, so we get x minus 3 in the bracket. If I take minus 2 as common from here, we get x minus 3 as a factor. So that gets us to x minus 3 is common, x minus 3, and then multiplied by x minus 2. Now this method we have discussed a lot of times in class 8. You would have already discussed in class 8. That's why I did a little bit faster. But if you still have any doubt, please do let me know. I'll make a separate video explaining the complete thing, because this explanation is pretty much needed for you to understand this thing also. Okay, so if you are very much clear, I'm way more than happy to leave it as it is. Now, if you are very comfortable with the splitting the middle term, you can use it if it is not said to use factor theorem. But since we have learned one new thing, it is very good for us to understand how to factorize a quadratic polynomial using factor theorem. Now, my dear friends, please listen very carefully. Over here, why do we do this? Why do we learn this? It's because when we go to polynomials with higher degree, splitting the middle terms becomes a little complex process, where factor theorem will help us to make it much more clearer. I will explain you in detail once we do discuss the cubic polynomial. We only have to discuss cubic polynomial. We can also go to a pi quadratic and all the polynomials with higher degrees. Yes, but for now, let's focus how to apply factor theorem for factorization in case of a quadratic polynomial. So now we have p of x equals x square minus 5x plus 6. Now, what is a constant term here? Okay, when we try to understand the constant term, we must also understand, if you have a quadratic polynomial and you find its factor, in what form will that be? X minus a multiplied by x minus b. Yes or no? Yes or no? It will be in the form of x minus a. Now, this particular thing, if you expand it, you will get it as x square minus a plus b x plus ab, right? Where ab is the constant term. So we are only focused on the constant term. This is the standard notation. That is why I mentioned it. But we will not go in detail about that. Why does that happen? So we are only worried about the constant term here. Why? Because we need the factors of the constant term. So factors of plus 6 are, what will be the factors? First of all, plus minus 1, plus minus 2, plus minus 3, and then plus minus 6. So in total of 8 factors. So what is the next step we do? We try to find the value of p of x at all of these factors. Now, why do we find at all of these factors? Listen very carefully. Now, when this is in the form of x minus a times x minus b, a and b are the x minus a is the factor, but a and b are the zeros of this polynomial. And when you have zeros of the polynomial, when you put that zero, put that zero of the polynomial in the zero of the polynomial, when you replace in place of x in the polynomial, we get the value of polynomial as 0, right? That is what is the remainder we have been studying. That is why we look for the constant term. Now I hope you get that. Now a little bit more I will explain it. As I already wrote this, if this will be in the form of x square minus a plus bx plus ab. A and B are the zeros of this particular polynomial. Yes or no? Now, since this is A multiplied by B, we look for its factors because the if A plus B is 6. We don't know if it is 1 and 6 or 2 times 3. Both will give us plus 6, right? So that is why we look for all of these factors. Now we will try to find the value of p of x at all these factors. So we will start one by one. Instead of x, now I substitute plus 1. Okay. So if I find the value at plus 1, we get 1 minus 5 plus 6. Because 1 square is 1, minus 5 times 1 is 5, which is obviously not equal to 0. No, wait. No, yes. 1 minus 5 is minus 4. Minus 4 plus 2, 6 is minus 2, which is obviously not equal to 0. Let's quickly find it out. P of minus 1. Yes, P of minus 1 is, P of minus 1 will be minus 1 square is 1. Now, minus 5 multiplied by minus 1 plus 6. So that will get us to 1. Minus 5 times minus 1 will give us 5 plus 6. Oh, which is obviously equal to 12, so that will not be equal to 0. Now, just observe, since 1 and minus 1 both are not possible, that means we have eliminated the possibility of plus 1 and plus and minus 1 and plus and minus 6, because this particular constant term is AB, right? Yes or no? So in AB, if it was minus 1, then it would have been minus 6 automatically. You could try to understand that because this is AB, right? This A and B are factors of 6. So we are trying to look for the values of A and B. Now let's try to get going so that it will be easier for us to understand once we keep going. Okay, so I'll make it a little bit, I'll make it move it up. So this will be vanished for a while. Don't worry at all. Okay. So P of 2, we have to find it out. So P of 2, it becomes 2 square is 4. You can observe it from here. P of 2 equals to 4 minus 5 times 2 becomes 10 plus 6. So now 4 minus 10 is minus 6 plus 6 is equal to 0. So what did we get? That one of the factors, one of the zeros of this polynomial is 2. So now can you quickly guess it? 2 times how much will be plus 6? Because plus 6 is the constant, right? Plus 6 is nothing but AB. AB are the zeros. So if A is 2, what should be B? It should be 3. I have guessed it. Let's quickly try to calculate. P of 3 will be x square will be 9 minus 5 times 3 is 15 plus 6. So 9 minus 15 is minus 6 plus 6 equal to 0. I hope now I'm making a lot of sense for you guys. So now what will be the factors of this? This will be equal to x minus 2 multiplied by x minus 3. Now you might think that splitting the middle term was easier, but this is way more easier than splitting the middle term if we practice it enough. Okay, let's quickly go through the other factors. I hope this makes a lot of sense. Yes, let's get going to the other problem, and I'll explain everything once more. I'll explain it in detail. So other problem is P of x equals x square plus 2x minus 3. Yes, so let's keep going. So x square plus 2x minus 3. Now over here we have minus 3. Minus 3 is the constant term. So for minus 3, what will be the factors? It will be plus and minus 1 and plus and minus 3. So now you can quickly guess it. If the factor is plus 1, the other factor will be minus 3, because plus 1 and minus 3 will only get us to minus 3, because this is nothing but A multiplied by B. So if A is positive, B will be negative because we have to get a negative number. If both are negative, we get a positive number, not a negative number. I hope that you are able to relate this. This is very, very beautiful thing of which what we observe over here. Okay, so let's try to find it out. So this one is named as P of X. P of X equals this polynomial. Quickly, let's find it out. P of 1. So P of 1 will be 1 plus 2 minus 3 because 2 times 1 is 1. So 2 plus 1 is 3 minus 3. In the first go itself, we were able to find the value. So 3 minus 3 is 0. Now, what will be our other factor? Let's guess it. Guess it fast. It will be minus 3. Let's quickly try to find the value to verify. P of minus 3. Minus 3 square is 9 plus 2 times minus 3 minus 3. Yes. So 9, 2 minus 3 is minus 6 minus 3. So what does that becomes? 9 minus 6 is 3 minus 3 equals to 0. That means the value of A is 1. The value of B is minus 3. So what are the factors of x square plus 2x minus 3? It is x, it is plus 1, right? Plus 1, right? So it will be x minus 1. Now it will be x minus of minus 3. So minus of minus 3, what can I write? I can directly write it as, I'll write it once more, x minus 1 minus of minus 3 becomes x plus 3. I hope that makes a lot of sense to you. Yes or no? So now I guess little by little you are getting cleared. Now once again, let's try one more problem, and this one is a little more interesting one. I'll quickly erase it. If you want to, you can just take a screenshot. Yes, let's do the next problem. I can easily shift to new page, but I don't want to right now. Yep. Let's change the ink orange. Now we have the polynomial q of x equals x square minus 7x plus 10. Yes. Now we have plus 10 over here. Now this plus 10 is nothing but a times b. Now it is plus 10. That means if a is positive, b will also be positive. If a is negative, b will also be negative. So plus 10, what are the factors of plus 10? Plus n minus 1, plus n minus 2, plus n minus 5, and then plus n minus 10, right? So quickly, q of 1 equals x square 1 minus 7 plus 10. You get 1 minus 7 is minus 6 plus 10. Obviously, it is not equal to 0. That gets cancelled. Q of minus 1, q of minus 1, q of minus 1, let's try to do it. So minus 1 squared is 1, minus 7 minus 1, you get it as plus 7 plus 10. Oh my goodness, this is once again not equal to 0. That means once we have cancelled out plus and minus 1, plus and minus 10 is also not possible. So the next job is, let's try to find out of plus and minus 2, which one of them will lead us to 0. So q of plus 2, yes, q of plus 2 equals, so plus 2, if we take it, we get 2 square is 4 minus 7 plus 10. Just miss. Wait. It should be not minus 10 at 7. I made a mistake because this is plus 2, right? So 7 times 2 is 14. So now 4 minus 14 is minus 10 plus 10 equals to 0. So that means plus 2 is A. Can you get what will be B? B will be plus 5. Quickly verify that. So Q of plus 5 equals 5 square is 25. 7 times 5 is minus 35, means minus 7 times 5 is minus 35 plus 10. 25 minus 35 is minus 10 plus 10 equals to 0. So what will be the factors over here? The factors for this particular equation, polynomial will be x minus 2, x minus 5. Why am I writing minus over here if it's plus 2? Because what did we discuss? The standard form is x minus a times x minus b. So the value of a is 2, the value of b is 5. I hope so far we are very, very much clear. Now, whatever questions we discussed so far, the coefficient of the highest power was always 1. But we have never not discussed so far if the coefficient is not 1. Let's understand. We have one example here. So what do? We make that factor as 1. Okay. So r of x. Now why do we do that? Because we want the factor should be sole multiple a times b. Yes, that is what we want. So r of x equals 6x square minus 5x plus 1. Yes. Now, why do we do that? Why do we make it as 1? Because when we write the standard form x minus a times x minus b, you can see over here we have 1 as the coefficient. That is why we make it as 1. So let's get going. It's very easy. We take the 6 outside the bracket. Now, once we have taken 6 as common factor, 6 is the common factor. Now, all these two terms does not have a 6, right? So we will add a 6 in the denominator. Means we'll divide it by 6, because divided by 6 and already we have multiplied by 6. So it cancels out. Okay. So 6 we have taken out. So that becomes x square minus 5 by 6x plus 1 by 6. Yes. So, my dear students, if you did not understand this process, just comment down, because this process, I hope you understood, because this is a class 8 concept. If you have not understood, just comment down. I'll make a small video and post it in the comment section itself, so that it's easier for you to understand. Now, as you can see, we have got the coefficient of x square as 1. Now, one thing you have to catch over here is coefficient of x square became 1, but the factor which we have, it became a fraction. That means 1 by 6 over here plus 1 by 6, this is equals to a times b. That means a is also a factor and b is also a factor, right? So sorry, fractions. So what are the factors of 1 by 6? We will take it as plus minus 1 by 1, plus minus 1 by 2, plus minus 1 by 3, and plus minus 1 by 6. Why? Because when you multiply plus minus 1 by 2 and 1 by 3, if it is plus and plus, you will get 1 by 6. 1 times 1 by 6, obviously you'll get it at 1 by 6. That is why we take these factors. So now let's begin to find the values of r of plus 1. So over here, it's enough if you find only the value of the polynomial in the bracket. Otherwise, you can also find the value of this polynomial, because both are nothing but the same polynomial, right? It does not matter. So this one is this one does not have fraction, so I'll choose this guy. So 6x square is 1 minus 5 plus 1, right? So as you can see, this is obviously 6 minus 5 is 1, 1 plus 1 is 2, which is not equal to 0. And obviously, if you do minus 5, this will rather become a positive. So minus 1 will also not give us. So that means plus and minus 1 and plus and minus 1 by 6, both of them are not possible. So we have eliminated that case. Let's now try to find out r of plus 1 by 2. Okay, plus 1 by 2, if you do 6 times 1 by 2 whole square is 1 by 4 minus 5 times 1 by 2 plus 1. So this becomes 2 3s are and 2 2s are. So we get 3 by 2 minus 5 by 2 plus 1. So if you take the LCM, we get 2. So we multiply this also by 2. So we get 3 minus 5 plus 2 divided by 2. So 3 minus 5 is minus 2 plus 2 is 0 divided by 2. That is equals to 0. So that means one of the factors is plus 1 by 2. So now since we have plus 1 by 6, so if one of the factor is plus 1 by 2, or let me write over here on the corner that a equals 1 by 2. Now what is your guess? Since it is plus by 2 plus 1 by 6, b should be 1 by 3, right? Plus 1 by 3. Let's quickly calculate it and verify. So r of 1 by 3 equals, so 6 times 1 by 3 whole square is 1 by 9 minus 5 times 1 by 3 plus 1. Yes. So 3 twos are 3, 6, 3 threes are 9. So that gets us to 1 by 3 minus 5 by 3 plus 1. Again, take the LCMs. So times 3 and divided by 3. So you get 1 minus 5 plus 3. Wait. This one is 2 by 3, right? Sorry. So 2 minus 5 by 3 divided by 3. So 2 minus 5 is minus 3 plus 3 is 0 by 3. That is equals to 0. That means the other factor is 1 by 3. So for this particular question, what do we get? X minus 1 by 2 and x minus 1 by 3. They are the two factors. Or they can also be written as 2x minus 1 and 3x minus 1. Now, your question, if you are questioning, why can we write these as 2x minus 1 and 3x minus 1? Then your question is really beautiful. But what is the answer for that? You must think about that as well. Let's try to understand. What are these? These are the factors, right? What does the factors do? What does the factors do? The factor divides the polynomial, right? Or if you try to understand from the remainder theorem perspective, when you try to find the zeros of these factors, they gets you the remainder. So let's find the value x minus 2 equals to 0. Yes. So that's how you will find that's how you will find the root or 0 of the divisor. So if you just try to find the root, you will get it as x equals 1 by 2. Okay, let's try to understand another perspective. Suppose I take LCM. So this becomes, there's 1. So 2 and 1 has an LCM 2. So I'll multiply 2 in the denominator. Whatever I do in denominator must be done in numerator as well. So 2x minus 1 divided by 2 equals to 0. So 2x minus 1 equals 0. Yes. So we get 2x minus 1, right? From x minus 1 by 2. So because I took it as, because 2 goes to the other side, 0 times 2 is 0. So we can always take it as 2x minus 1 and 3x minus 1. I hope that makes a lot of sense, and that is how we factorize. You can try to factorize this particular question. You can answer in the comment section. I'll tell you if your answer is correct or not. Okay, 6x squared plus 17x plus 5. Similarly, you can follow the same procedure. I've kept the 6 as it is. Let's try to understand how do we factorize a cubic polynomial. Okay, so when factorizing a cubic polynomial, there are few steps which we must follow. The first thing is p of, let's suppose we have a polynomial p of x, which is a cubic polynomial. First thing we do is we take x equals a, where p of a equals 0. We, with the help of factor theorem, we try to find the first factor. That is what it means. Okay, what do we look for? We look for the constant term once again, minus 120, and then proceed forward to its factor and try to find out what is the first factor out of these. Then what do we do? Then after we have got x minus 1 as the factor, we divide it with p of x, and we get such an equation, p of x divided by x minus a. And then after that, whatever quotient we will get, since x minus a is the factor, that means since the divisor is a factor, the quotient will also be a factor. That is what we learned from the factor theorem, right? So that, since that will also be a factor, we factorize it using splitting the middle term. We factorize it once again because we only want linear factors. Yes, let's quickly do this question and then we will wind up. Now this has been a little lengthy video. I hope you are tired. You can pause, you can just refresh and then come back so that you are refreshed to listen to this particular question. Let's begin. So p of y equals this particular question. Let's try to understand it. Okay, Now P of y is given as 2y cubed plus y squared minus 2y minus 1. Now what did we learn? The first thing we have to understand is, since this highest factor is not 1, we will try to make it as 1. In this case, if you solve directly by taking as minus 1, that works, but let's go to the common process so that we don't have to memorize every time. So y cubed plus y square by 2 minus 2y, sorry, minus y, because if I divide it by 2, we get minus y minus 1 by 2. Now once I got minus 1 by 2, what are the factors I'm looking at? What are the factors of minus 1 by 2? Factors of minus 1 by 2 is plus minus 1 and plus minus 1 by 2. Yes or no? So now we will try to find the value of P of 1. Once I got the value of P of 1, let's try to quickly get it. So 2, 1 cube is 1, so 2 plus 1 square is 1. Then 2 times 1 is 2 minus 1. So 2 minus 2 is 0, 1 minus 1 is 0. So I got the value very, very directly. So that gets P of 1 equals to 0. That means the first factor is x minus 1. What is the next step? The next step, as discussed already, is we will be dividing the polynomial with the help of x minus 1. Okay, now x minus 1 becomes the divisor. We will divide the polynomial throughout with x minus 1. So there are two terms in the divisor. So how many terms we will take from the dividend at a time? Obviously 2 at a time. So x minus 1, we will take the first 2. So what should you multiply? Wait. This should be y minus 1. I'm so sorry. This should be y minus 1 because we have the variable as y, right? So this should be y minus 1. So what should you multiply to y to get 2y cube? You must multiply 2y square. So 2y square, if you multiply, you get 2y cube. To 2y square multiplied by minus 1, you get minus 2y square. So this is minus, this is plus. Sign changes, right? If you have doubt, you can comment down. I'll make a separate video. So plus 2 plus 1, we get 3y square. Since we cannot proceed further with only one dividend, we will bring this guy down. So we get minus 2y. And then we proceed further. What should we multiply to 3y square into y to get 3y square? So you multiply plus 3y. So plus 3y times y, you get 3y squared. Plus 3y multiplied by minus 1, you get minus 3y. Once again, the sign changes. Yes, let me change the color also. If the sign is changing, why not color? So this will be 0. So minus 2 plus 3, you get y minus 1. And then you must multiply it by plus 1. You get y minus 1. And the remainder is 0. As we discussed, since y minus 1 is a factor, obviously the remainder was supposed to be 0. So this quotient which we have got, that is 2y squared plus 3y plus 1. This is also a factor. Now we can split it using middle term. So 2 times 1 is 2. So we must split the middle term. So 2y squared plus 2y plus y plus 1. So this gets us to 2. We can take out common. What is the common? We can take 2y as common. So if you take 2y as common, over here y is common plus 1. Plus 1, if you take it common from here, you get y plus 1. Now y plus 1 is common throughout. So y plus 1 and then multiplied by 2y plus 1. Yes? So what are these are the two linear factors, and there is one linear factor we have already calculated. So we get y minus 1, y plus 1, y plus 1, and 2y plus 1. These are the three factors of this particular question. I hope this made a lot of sense, and cubic polynomial is very, very much clear for all of you. Thank you so much for being with me for so long and trying to understand factor theorem in detail with reasons. If you still have doubt, do let me know in the comment section. We will try to understand that in very much detail You were listening to Apna Gurukul Maths, one little step towards success. Thank you so much for your patience hearing. We'll see you in the next video. Until then, keep smiling. Jai Hind.